Okay, first of all, welcome to the training for the new tool that we have in our facility. I'm quite excited to share with you all the capabilities that this tool has. And also I'm excited to open it because I know many of you have been waiting for a little bit of time to be able to use it and then fabricate your mask like before, and also to print some samples on it. So first of all, I want to remind you that this training is just to let you know how to use the tool for single exposure or mask fabrication or wafer exposure. Okay, it doesn't matter what is the size of your substrate, but it's just a single layer printing. But it's not giving you the access to the tool. Okay, after this training and at the end of the presentation, I'm going to explain you how to register for the next qualification sessions that I'm going to schedule for starting on the 2nd of April, okay? And it will be a new system as well to register, because just I spoke to Basil, who is in charge of the Infinity system, and then we are going to organize all the qualification sessions on Infinity. So everyone that requires the qualification can go directly to the sessions in the calendar and register by yourself. Okay, so you don't need to send one email and then I don't need to schedule the session. You just go there and register. To get access for these qualification sessions, of course, you need to attend this session previously. And I also want to share with you some rules that we have in Infinity regarding the usage of the tool and the booking time. Because like the previous one, this tool cannot be booked for more than 24 hours. The previous one was 12. This one is 24, okay, per week and per user. And also there is one rule of no show. So if after 30 minutes from the time your booking starts, you don't show up and enable the tool, the reservation will be canceled. Okay, clear? This is very strange because no one is answering, so I feel speaking alone. So let's share with you, I want to share with you the presentation that will help me as well. So I'm going to share the screen. This one. Okay. So can you see the screen?
Yes, we can see
it. Yes.
Okay. Thank you. So starting for the first one, going into presentation mode. So as I said, so this is the new system. The name of the system from the company is Heidelberg DWL66+, and it's a laser lithography system. And the training for today is going to talk mainly about single sample exposure, okay? And we will be using for that the exposure wizard. I forgot to say, if you have any question, just speak out loud.
I think you put the presentation mode, but different, and another screen, because we are seeing.
You are seeing the other one.
Yeah.
Thank you. So maybe I need to share the other one, okay?
Erika, just share it and then switch the display on the top. Just share the screen.
I'm sharing the screen. I just need to change the screen that I'm sharing, I think. Yes.
Erika, we see the PowerPoint presentation. Yeah, that's okay now.
Yeah, now it works.
Oh.
Yeah, that's good.
Okay, thank you. So I don't know if I'm passing through the slides or not. Wait a minute. 1 minute, eh? Okay. First, I want to start this and then I will now. And then I go to zoom. I move you from here. And then I share. Now, yes. Okay. Okay. So I just need to see that when I'm pressing this, I'm moving through the presentation. I am moving?
No.
No, right?
No.
I don't know what's happening. One minute. Share. This one. Share. Maybe I just need to share the PowerPoint. Yes, now. Can you see it now? Like I'm moving?
Yes,
Yes.
now you're moving.
Okay, great. Finally. Okay, thank you. So as I was saying, this is the name of the tool, and the name in Infinity is Lead 027 DWL66 plus Laser Writer. Okay, just if you want to find it. And as I was saying, this training is about single sample exposure using the exposure wizard that I will show you later. Okay. So this is a little bit the outline for the training today. So I'm going one by one, starting for meeting the DWL66 system. And it is a high resolution maskless laser lithography system. And with it, you can expose directly onto substrates coated with photoresist layer. If you are familiar with the old one that we were having, the previous one, it was mainly used to expose mask. Also, you could expose wafers, but you couldn't expose small samples. Instead, this one is much more versatile and you can expose any size of sample if it's coated with a photoresist layer. So for those that are not familiar with maskless laser lithography, they don't know. Okay, this is a lithography process where the radiation, instead of being transferred through or projected from a photomask, is directly exposed from the design onto your substrate. Okay, what we have inside of this laser writer, we have a continuous wave diode laser at 405 nanometers wavelength. So it's in the range of the UV. And the maximum laser power that it can give is 300 milliwatts. So with this laser inside, we are facing a exposure laser class 3B. But like the previous two, it has some engineering measurements for safety. In fact, it has a window interlock. So if the main window is open, the laser stops. And also all the path of the laser inside is covered with black and locked covers. So in the previous one, you could remove. In this one, you need a key to remove. So it's even safer. So all of these are making the instrument classified like class 1. Even though it has another laser inside for the interferometer, for the stage position. So this laser is class 2. Less hazardous, but still hazardous. And whenever you are loading the sample, you are kind of exposed. Of course, it is not at eye level, so it's very difficult that you get exposed to that. But I have to say that the instrument, when you are loading the system, the sample, is an instrument classified as class 2. So what are the main parts that we have in the system? I forgot to mention, this is the picture, and it looks like very similar like the previous one. So the main parts. We have a main flow box, and also it is an environmental chamber that is keeping the temperature constant. And inside of this flow box, we have the stage, the main base, which is super heavy to make it stable. We find the writing head, all the motors, the interferometer, and the optics system. Next to it, and this is the new thing that we didn't have before, we have this tower, which is the handling unit and pre-alignment system. So inside of there, we can place cassettes full of samples, either wafers or mask. And we have one arm that is bringing them from the cassette to the stage with the pre-alignment system for wafers, lining them using the flat. So apart from that, and you cannot see in this picture, but you will see whenever you come to see the real tool, we have the electronics rack and the PC cabinet. Now the PCs and all the electronics are in the same tower, and this tower is behind of the tool. And of course, we have the screens for the PC. Someone is writing in the presentation. That was funny. Okay. So going to the next point, we have, or I'm going to present what are the key features of this tool and what these features are making this tool much better than the previous one. And the first one is like it has 3 different writing modes. These 3 different writing modes are with 3 different, or they come with 3 different writing heads, and they have, of course, different capabilities that we will see later on. So we can achieve different resolutions and also different writing speeds. Like the better the resolution, the slower the writing speed. The second thing that it has, very important, is that with this tool, we can perform 2.5D or gray-scale photolithography up to 1,000 levels of gray. So this is a feature that we were not having before. And also the tool is capable of doing alignment. So with the previous one, we were doing only single layer. And in this tool, we can just perform one layer onto another layer and do the alignment in the front side, but also in the back side, using the back side of the wafer or of the substrate. And the last thing I already spoke about is the automatic loading and pre-alignment system, because this capability will allow us just to program some exposures. Like imagine you need to print 4 photomasks and you just program the tool to be working during the night, and in the morning you will have 4 photomasks completely exposed, mask or wafers. I have to say that the automatic loading is limited, of course, to mask or wafer. Okay, it cannot be done for small samples. Small samples, they need to be loaded manually. More things. So now I'm going to speak about the write heads or the different writing modes that I was talking about. And it has 3. Okay, we have 3 different write lenses or write heads. We have the 2mm, the 5mm, and the 20mm. The 5mm one is the one that is going to be a standard. Okay, so the tool will have always installed the 5mm write head, unless you need or you require to do it with another one. And but to do this exchange, you need to be an advanced user, and then we will talk more later about this advanced training. And these are some of the characteristics of each write head, okay? So the focal depth is different. Of course, the minimum feature size, and some of you already know that this tool can achieve 0.3 microns with a high resolution. With the 5 millimeters, you can achieve 0.8, which is not that bad. And the 20 millimeters is 2 microns, okay? When we are talking about minimum feature size, we are talking about the size, but not, for example, if you are thinking in spaces and lines, because this space between the lines is going to be bigger than the line size. And this, you can see it after this, and it's written the minimum lines and spaces. So this is the space between the lines. Also, the write speed is changing a lot. In fact, you can just see here, and I wanted to put here what is the expected time for a wafer or a 10 by 10 centimeter area of exposure with each writing head. And you can see the huge difference. For example, for the high resolution, it will take 56 hours. So more than 2 days. But just with the 20 millimeters, it will take 15 minutes, 16. So the difference is very high. Okay, or very big. So next thing, we will talk about the checks, because we have different checks due to the automatic loading system. And each check can accept different type of samples. So these are the 2 ones, and it's very easy also to exchange the check. If you take the training for the qualification, I will show you how to change the check. And these are the substrates that you can use with each of them. As I mentioned before, the automatic loading check can accept only plates and wafers. It cannot accept a small samples, but instead the manual check can accept up to like that. The sample can go down to 5 by 5 millimeters squared. So very small sample. The maximum substrate thickness is 12 millimeters, and the permitted materials, you have them here. Of course, I'm going to send you this presentation as well, okay? So you don't need to remember. And also I'm going to send you the SOP for this tool. So the next thing is to understand how we can perform the, like a single exposure. What is the workflow? Okay. So first we will need to design our pattern using any layout software that you like. We have in the tool installed LED, Clewin, and K-Layout in case you need to modify anything during the fabrication. So once you have your design file, and I will speak later about the formats that you can bring this file, we will bring it to the same application that we were having before. I think some of you will remember, like the users for the lead 15 will remember. This is the icon that you will find on the desktop of the computer. So you load it into this, and then it will convert it into leak format. This is the format that the tool is using to expose. So with this format, we will bring it to the next software. And this software is the one that is operating the hardware of the tool. So once we load it there, we can expose. After exposure, of course, we will need to develop, or if it's a mask, we will need to develop, etch, and clean. And then, oh, sorry, this will be the last step, the final inspection. So this is the workflow. And now I will go into how to load the substrate. From now onwards, the training will be focused on mask. In fact, I have now one video to show you how to load the sample on the stage, a mask. But if you come to the qualification, I will show you also how to load a wafer. It's exactly the same, but we are only changing the centering tool. So let's go and see the film on how to load a 5-inch blank mask. First of all, to open the flow box, switch on the light. And this is the stage and the alignment 8 for mask. It has this pin on the back. And we need to fit it inside of the slot. You can see some alignment marks for the different sizes of mask. And now we need to place the sample on the stage. The photoresist facing upwards. It's just on top, you see the 5mm right head. When it's aligned, switch on the vacuum. Check that it's not moving. And then remove the centering tool. Now switch off the lights. And close the flow box. So now I will stop sharing this presentation. Okay, because I need to start sharing the other one. Okay. Now I will show you how to do this translation. I will follow all the procedure that I share with you, like the workflow to expose. And I will show you how to use both softwares. Okay. So now let's see if I do it correctly this time. I will share this screen here. You tell me, okay, if you can see. So can everyone see the?
Yes, yes.
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 Okay. So as you can see here on the desktop of the PC, we have this application that I showed you. So to do the file translation, we just double click to open it. Can you see the windows when
Yeah.
they are opening?
Yes.
Yes.
Ah, perfect. Nice. So from here, this is the main window from the software, okay, for file translation. From here, we just need to click in File, New Job, or into this icon that you see. And then this is how we start a new translation job, okay? So here, this window is asking us for the name that we want to give to our job. I will use the same name that I'm using, training, okay? And we click OK. Now this window expands. And from here, you see we have this frame, the source file frame. And from here, we need to add the file that we created. And I didn't mention before, but to bring the file into the tool, you will need to send your file through your email, connect to your email, and download it and keep it in one of these folders. You see these folders? These are the formats that you can bring your file: CIF, DXF, and GDS. This one is for grayscale design, so forget about this one now for now. Okay, so you just bring your file inside of here, create a folder with your name, and then put inside your file like this one. And I have to say that there are few rules that you need to follow, okay, while you are creating this design file. And one of them is the name that you give to the file. This application will fail if the name of your file contains any symbol or a space. So please use only letters, numbers, and underscore for the name of your file. This also affects to the name of the folder where you keep your file. And this also affects to the cell names that you have inside of your design. Okay? So for that, avoid to use any spaces. If you need to put one space, just put the underscore and just use letters or numbers. Because if you just use the other one, this application will fail. Okay, so this is the first rule. I will be talking about these simple rules to avoid problems when translating your file. So how to bring this file into here? I just need to click in Add, select the type of file that I want to bring. In this case, I will use CIF. And I select the file. Once I have the file selected, I just click Open. And one window will open to select some few like characteristics about the file. Normally, I need to select the top cell. I need to select which layer, but in this case, I have a single layer. I have to select from here. Normally in CIF is always automatic. And the scale. The scale I leave it one by one, but I want, because I want to have the same size. From here, when everything is set, I click Create Default. So now my design has been transferred, and to see that all the design has been transferred perfectly, I can use this button here that says Viewer. And when I click the Viewer, this is new. Because the viewer that we were having before, I think for the users that were all users, the other two, it was different, the viewer. This viewer is quite easy to use. You can see here all the tools that you can use to move around and to check inside of the design. And also now you can use the mouse. So now, for example, I'm just using my mouse wheel to zoom in and zoom out. But I can also zoom from here. I can zoom out from here, or if I can see, I want to see again the whole design, I just click Show All. Also, when I zoom in, if I want to move through it, I can use the arrows to go to the left, to go to the right, to go down, to go up, and to see it again like this. So more applications for now, for example, these buttons is just to see the design in a different way. For example, now I'm seeing all the polygons that are filled. Okay, so all the polygons, I go closer for 1 minute. It's just the Kaust logo. If I click in this one, I just see the lines. And if I click here, I just see points. But this is just different ways of seeing your design, nothing else. So this is just to explain you that this viewer is a viewer. So it's just to check your design. You cannot do any modification on your file from the viewer, Okay, it's just to check that everything has been transferred. Okay, so from here, it has also a measuring tool that is kind of working very nicely. If you want to measure how much distance you have in one of your features, for example, let's move into this one. I will show you how to measure. I zoom in, I zoom in, I move, I zoom in, and I move to the opposite side. For example, I want to measure the square. So I just click on this arrow, go with this cross to the first point of measurement, and then go to the second one. And it's supposed to measure. Now it's failing. Okay, I think I clicked twice. I go out, viewer, zoom in. Okay. And then measure. Now. And here, you do this with the mouse. And here you can see where is the first point, what is the second point, and what is the distance in X and Y and the distance between of them, okay? So I close the viewer because I see that my design is perfectly fine. And from here, one thing that is important to choose when you want to write is the right lens that you are going to use. So if you just click on this arrow, you can see the 3 writing heads that we have. So you have to choose the one that you want to use. In my case, I want to use the 5mm. And then the pixel size and the stripe width is coming automatically, okay? About the design label and overlap area, do not worry for now. And we just need to come back to these 2 tabs. One is the justification and one is the expose options. So I will go
Erika?
into the, yes, tell me.
I just have a question.
Yes, go ahead.
Is there any recommendation for the types of writing lens we should use?
Yes, it depends on the resolution that you want to achieve. If you want to achieve the 300 nanometer, you have to go for the high resolution. If you just need to achieve 1 micron, it will be the 5mm. And if you just need, for example, 5 or even bigger, I would recommend you to go with the 20mm, because as I don't know if you remember the table that I showed previously. Because if you just need, for example, or your biggest feature is 5 microns, and you use the 5mm write head, it will take around 3 to 4 hours to write your pattern. But if I'm talking always about a mask, okay, a full mask. But if you use the 20mm, it will take you 15 minutes, 16 minutes. So you can use either the 5mm or the 20mm, but if you prefer to spend less time writing your sample, so you can go with the 20. Instead, if you need high resolution, 1 micron, don't go with the 20mm because you are not going to have a good resolution, okay, for your features. So it depends on what you need. Did I answer?
Yes, Erika, thank you.
Okay. So now we will need to arrange the expose options parameters. And here we find the standard options that you see here in this frame. This is an important frame because here we have the option of clear and we have also the short mode. So clear, if I click, it will transform into dark. And this is a key option because this will be affecting which areas are going to be exposed and which areas are going to be non-exposed. So it will be, in the end, the areas that you want to open or the areas that you want to keep on your substrate, okay? So this is important, but it's very simple. The tool by default will always have the clear mode. And the clear mode means the polygons have, the polygons are going to be exposed. And if you are using positive photoresist, these polygons will be open. Okay, and this is the clear mode. Instead, if I choose dark, dark is going to do the opposite. So the tool will read your polygons and will expose the whole area, but your polygons. So your polygons will remain if you are using positive photoresist. If you are using negative photoresist, it will be the opposite, okay? Anyway, we will talk about this while you are doing your qualification, because if you have any doubt on how you want your design to be, if I'm using this photoresist or that photoresist, we will solve all the questions. And also the short mode. This short mode is useful whenever you bring if you realize that you are bringing polygons that are enclosing another polygons. This is another rule for design, okay? Normally, I recommend to everyone just bring one layer per each exposure, because you just need one layer per each exposure. So you can design in your software as you wish. If you want to have 50 layers in your design, I don't care. And it's not going to affect. But when you export exactly the layer that you want to expose on that substrate at that specific moment, you just need one layer. So export only one layer to avoid problems. Okay, because if one polygon in one layer is covering the other one completely, you will have everything in black somehow, or you will have all this area exposed. Or even worse, you will have just a dark area or exposed area, okay? So sometimes this option, if you realize that you have one polygon that is enclosed in other polygons, is working. If you click it, it will help you. But my recommendation is just bring one layer and avoid having big polygons enclosing small polygons. Is this clear? Yes. Okay.
Yes.
Thank you. So apart from that, there is one more option, and this is mainly when you are using the dark exposure mode, and is the frame. And this is quite useful mainly when you are fabricating photomask. Just to add a little space between the last thing that you have on your pattern, or the last polygon that you have in your pattern, and the exposed window, okay? Because the tool is understanding the exposed window or exposed area as the size of your design. And I'm going to show you in the justification what I mean. In justification, we have the exposed window, and here you have this size that I will transform into millimeters just by clicking on top of the, I would say, on top of the units, you can transform. And you see the design width and height is coincident now with the exposed window, because this is the exposed window, this is the design size in both axes, okay? So what happens when you choose dark and you have a positive photoresist? Okay, if the last polygon, imagine it's a circle, and the exposed window finish just where this circle finish, you will have the chrome, the rest of the chrome that is not exposed, touching your device. So you don't have a space between the last polygon and the rest of the frame, let's say, of the non-exposure area. So to avoid this and have your device separated from this other area, you can add a frame, okay? And this, we will do it in expose options, clicking in yes, and adding, just for example, for this one, I will add 3 millimeters on each side. And this option is going to add 3 millimeters to the left, 3 millimeters to the right, 3 millimeters to the bottom, and to the top of my design, in a way that when I come back to the justification, I can see the difference, because now the exposed window is 6 millimeters bigger than the design size. And it's just because of that. It's quite useful when you choose that. If you choose clear, don't worry, because this is not applicable. So now we already understood then what is the exposed window, these numbers, and I'm coming to explain what are these numbers, that left border, upper border, lower border, and right border. Okay, this number minus 51, 51, minus 51, and 51 is the distance that I have between the 0, 0 and one of the edges of my design. So the last thing I draw on the right, the last thing I draw from the 0, 0, not the center, from the 0, 0 to the left, to the right, to the upper, and to the lower border of my design. So these numbers will give you the idea if you have your design completely centered. If your design is symmetric and is completely centered, this number should be the same, like in this example that you see. Okay? If you see any discrepancies between these numbers, maybe it's because you have some letters on top of your design. Even though your design is symmetric, you have some letters, or maybe your design is not symmetric and that's it. Okay, but you need to pay attention to this, because the tool is going to grab the 0, 0, not the center of your design, which is different, the 0, 0, and is going to expose it in the center of the substrate. Okay, so another recommendation for your design is to be coincident, the center of the design with the 0, 0. Is this clear? We have
Yes.
one, okay, thank you. We have one more solution in case that, because some users maybe are new, or some people can be new to the design software and they don't know exactly how to center. My recommendation then is just create your pattern in a symmetric way. And if your pattern is not symmetric, you can make it symmetric, just putting some alignment marks or some, I don't know, just the cow's logo at the same distance. So you create a symmetric design somehow. And then you can click automatic centering. If you click into here, in this area, you see automatic centering. The tool will be centering your design automatically. Okay? But this only works, and this you have to remember this. This only works if your design is symmetric. Okay, more things. Also, you have the option to set one offset if you want just to move your design to some area and you know exactly where to put it. You can just type it into here. You can mirror as well. For example, if I open again the viewer, I don't know if it will do it with this viewer. Let's see. And I click mirror. I didn't test it if it's automatic or not. No, it's not automatic. So I close. And I open again to see if it's mirror. No, it should be this one. This other viewer. And now it is changed because before it was in the other direction. So you can mirror either in Y or in X. But to see the results, you have seen now that it's not updating automatically. You need to close the viewer and you can open either again from here or from here. Okay. And now your design is just mirror, but it's mirroring the whole design. So let's continue this one. Okay, in reality, I don't want to mirror. It was already good for me. So I already established all the characteristics that I want, or the parameters for my job. Okay. And now I can go and complete the task. So after I set all these options, okay, I say, yes, I want it dark. And from here, I don't need to do anything else. I click complete task. And now the tool or the software is going to ask me again to give it a name. And it's asking me, is this file name that you set in the beginning the correct one? If it is, you can just click save. Please don't go and create one folder, because the software will create the folder, and inside of the folder, all the files that it needs to do the exposure. Okay, so you just need to click save. Once I click save, this appears because I'm overwriting an existing file. So I click yes, and it will give you an estimation of the time. Have you seen this small window appearing, disappearing? So an estimation time for exposure, okay? Normally it's less. And now two more buttons are appearing at the bottom of the window. One is expose online and the other one is expose offline. The one that we will choose is expose offline. This means that the file is going to be converted completely now. And then when we call it from the other software, it's just expose. And this is the option that we will take. So we click expose offline. This is because I'm overwriting one file. I click OK. And now this window appears with the percentage of the file translation. Once it's done, it will tell you it's done. And we just need to click finish. Okay. So now we can continue. And now is the time when we are loading the sample. The video that we saw previously, and I already did it before starting. Let me check again. Yes. So I have one plate inside of the machine. And now I will start the exposure. So to do the exposure, we need to operate this software. Normally, I think it will be open, but I wanted to show you in case that you have your the computer and the software is completely closed, how to open and how to log in, because there are several users. So we double click in menu. Are you seeing now how it's opening? Like, yes? Okay. And now this window is, this window will give you the option to choose the user. For you, for now, you will choose DWL66+ basic, okay? And the password for this is the same, but it's just D in lowercase. WL basic. Or without spaces, lowercase. DWL basic. Okay? We click log on. And now you see this screen, how all these options are becoming like a green tick. We have to see that all these ticks are in green. Perfect, it's working. It's kind of checking all the system. Now, so this is the interface that you will find, okay? And it's super simple. It's much more simple than the previous one, just for single exposure. Is really easy. So from here, we have the exposure wizard. That is the one that we are going to use. If by any case this is closed, because I can close it, and you can see just the window like you see now, you have to go to this menu, click on Wizard Drive, Exposure Wizard. That's it, and it will open, okay? This window is floating now, but when I move it, can you see this thing in the middle that appears? So if I release it when the arrow is in the middle one, it is placed in here like a window, a standard window, like fixed window in here. So,
Erica, sorry, the cross is not visible.
sorry,
The placing cross is not visible on the video.
no one has seen it? Is it because it's a little bit, if not, this is not really important to place it. I'm going to close it again and do it again. Just, so I go to Exposure Wizard, and then now, can you see across in the center of the window that is blue, that has 4 arrows?
No.
No.
So forget about it. You just leave it floating. It's working. And I will show you during the qualification, because maybe, I mean, this is from the software, so I don't know how you can see this cross. Anyway, you can open it, leave it like it was before, and work with it. It's not important. So from this exposure wizard, we have several steps here. You can see the first one is orange, and then the rest are not active yet, and they will become in orange while we are progressing through the process, okay? And it's just guiding you through each step. In fact, here on the right side, you can just read a small explanation on how to operate this area. Okay, so what are the options that you can access from this step? So first of all, we will need to choose the type of substrate that we want to expose. So we open this and we select. Okay, from here we have mask, wafer, 4-inch, wafer, 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 and mask. Okay, so we are going to choose 5-inch mask. And the size comes automatically because I choose just a 5-inch mask. So it's 5 by 5. I have already loaded the substrate. That's why, and then this is selected. And I will click unload when done. Because this checkbox will make the tool to bring the stage to the unloading position whenever the exposure is finished. Okay, so I click in this, and then I can go now to the next step, which is now in orange, is the design selection. So from here, we see several folders. And normally, when you translate, the file comes to general. Okay, now currently we have several RFS in here already. But you can see here the design that we just did. If by any chance this is not showing you your design, it can happen that you need to update. To update or refresh, okay, the files, click into this update all designs. And this will bring the last converted designs into this window. So from here, we choose by double click. And then you can see into the design information, what is the design that you have chosen. So is the training, the conversion type of line, and more options like the writing head that you choose for the exposure. From here, we continue and we go to edit exposure map. And in this case, because now we are only doing single exposure, we don't need to modify this map, okay? Because we are going to use the same options for the whole area, okay? I will explain farther away because for now, I'm going to give you the standard parameters for mask fabrication. But if anyone wants to expose with a different photoresist or a different substrate, we will need to adjust the process. And this is going to be another advanced training that I will provide to anyone that requires, okay? So I will help anyone that needs to adjust the process on how to do it. So for now, we leave it like this. We don't need to increase the number of columns or number of rows because from here we can modify and have more because we have just one design. And then we move to the fourth step, which is the final one, to set the parameters for exposure, okay? In this case, we can modify the laser power. And for photo mask, for now is 63. Okay, 63 millivolts for nanofilm mask. The intensity, we will leave it in 100%. The filter, we will leave it in 5. The focus that we will use will be optical, and the offset for the focus has to be -1, which is by default, in fact, is written in here. The global alignment system that we will use is just to find the center of the mask, but this will be done automatically. So that in the moment that I press start, the tool is going to bring the sample to the center or underneath the lenses. And then we'll start all this procedure where the tool will be searching for the edges of my sample to detect the size and to detect precisely where to expose, which is the center of the plate, okay? So after finding this or selecting this, we don't need to set any offset that you can set as well in here. And we will expose only one or once. So the exposure is done only once because this is an option that you can use whenever you have a thicker resist. If, for example, the maximum power is not enough to completely expose, you can do several passes, okay? The laser mode after the exposure, we will leave it as default. And we don't place any delay for the start of the exposure. So in the moment that I press here in this button starts, the exposure will start. And now you don't see anything different because now the tool has moved the stage to the center and it's going to start finding the mask center or the sample center. to expose the center, to make coincident the center of the design with the center of the plate. When this is finished, we will have just another window saying that the exposure was done. Please remove the substrate and press OK. And we will need to unload the sample in the same way we load it, but reverse. So we will open the window, remove the vacuum, take out the sample, and close the window. And that's all we have to do for this exposure. So now I'm going to wait because I also want to show you that also the tool is going to tell you how much time remains or how much time it will take to perform the total exposure of this design. But now I want to see. Now it still is reading. Any questions for now?
Yes, Erica.
Yes, go ahead.
Do we need to turn on the laser as before in the beginning, or it is automatically on?
It's automatically on. You just need to choose. Have you realized when I was going through the last step, I need to tell the tool if when I finish, I want to leave the laser off, I want to leave the laser on, or I want to leave the laser in default mode. You need to choose what you want to do when you finish the exposure, okay? And for now, just leave it in default. But you don't need to switch on the laser. In fact, this was one of my questions to the engineer as well. Like, do we need to wait for a little bit of time to warm up the laser? He said, no. The only laser that needs to warm up before we use the tool is the interferometer laser when we completely shut down the tool. But this is not going to happen to you, okay? Because this is just in case we switch off the tool by emergency or because there is a power shutdown or whatever. The first time we enable again the tool, we need to wait at least 30 minutes for the interferometer to warm up, but nothing else. So you don't need to worry now to switch on the laser. Any other question?
Hi, Erica.
Hi.
Can you show us how to do the alignment today?
No.
Okay.
So this is a
first
real advanced training. So, and I wanted to open the tool fast for people to allow people just to fabricate their own photomask or to fabricate any sample. But the alignment, no, still not. And this alignment is going to be a separate training. So it's not in the general training because not everyone needs to align and it's a more complicated procedure. So I will train specifically the users that really need to align.
Okay. And one more question. Just now you showed we are using the automatic chuck, right?
No, now we are using the chuck for manual loading.
So is a manual chuck or automatic chuck?
The chuck is not automatic. The chuck, you need to change it manually. But the chuck has to be changed when you want to load the samples with the handling unit, okay? In fact, this is a good question that you bring because we need to be very careful. Because if we are using the wrong chuck with the automatic loading, we can crash the handler and break it. So for now, it's me or Manuel, which is the second owner of the tool, the ones that are allowed to change the chuck in case a user wants to use the automatic loading. And always when this person is trained, because for now also I didn't give the training for the automatic programming of the tool or using the handler. It will come later on.
Okay.
And you need to be already experienced user, let's say, because this is critical. I mean, you can break the system just if you just don't realize which chuck you have is the wrong one. And I
Okay, thank you.
mentioned the email. Like
Yeah.
this is a training for single exposure.
Mhm. Okay, one last question. Because we are using the highest resolution, so should we, what's the requirement for the photoresist? Because
Yes, like in fact, there is a specific way to get these 300 nanometers. So you cannot use any substrate, you cannot use any conditions, you cannot use any photoresist. You have to use a specific methodology that I will train people on doing it to get this resolution. Yeah.
because before we bought plenty of blank mask. So can we use this blank mask to get a 300 nanometer resolution?
No.
Okay, so we need to some special mask.
No, it's not mask. May I
Yeah,
ask you why
I
you
mean the
want?
blank
May
one.
I ask you why you want to have 300 nanometers on a mask?
Actually, I just first just a small question to know. But for my sample, it's not for mask, for element small samples, not mask.
So it's for your sample.
Yeah, it's for my sample.
Because you asked me for mask and I say no, you cannot reproduce 300 nanometers onto mask.
Okay, I see.
You just can reproduce in the way that I will explain to the users that really need to achieve this resolution, because believe me, that is not obvious. It's like you need to coat, I mean, you need to have a silicon wafer coated with anti-reflective layer, and on top of this, a high resolution photoresist, then you can achieve that. I don't know who is calling me. Anyway.
Okay, thank you so much, Eric.
Can you wait a minute, please? Sorry, it was a scam. Okay. Any other question about this high resolution?
Hi, Eric.
Yes, hi.
Let's say the highest resolution is 300 nanometers. Does it mean that we need to make both the minimum line width of the polygon 300 nanometer and also the minimum distance between the polygons 300 nanometer, right?
No.
Only the line width.
Yeah, the line width, it has to be like in total, the pitch should be 1 micron.
Pitch is the minimum distance between two polygons, right?
Yes. Like from the
1
middle
micron.
of one line to the middle of the next line, it has to be 1 micron.
So the polygon line width can be the 300 nanometer.
The polygon size is
Okay,
what
okay.
it can be 300 nanometer. Yes.
Okay. I see.
And I'm talking about lines because, for example, I cannot promise, and we will need to make tests because we just received the tool now. We need to do many experiments to get a good knowledge of what kind of polygons we can get and what is the size, because it's not the same when we are talking about reproducing lines or reproducing holes or reproducing the squares to have the corners. It's not the same. It doesn't matter if it's this tool or is the ABL or is another tool. In photolithography or lithography, in the end, it's like this. So for now, we have proven, because it was an acceptance test for the tool, that we can get 300 nanometers lines with a pitch of 1 micron. And this is what I was showing in the table. I think I stopped sharing the screen, right? So I will minimize this and go back to the presentation. Zoom. 1 minute. And share again, sharing the presentation. Here, okay. Share. You can see, right, again, the presentation?
Yes.
Again, the same, I'm not moving, yes. Okay, here. So when I was talking about, wait, okay. This is faster to share in another way, this one. Okay, share. Share screen. Why it's not here? Screen two, it's okay. Share. Okay, I will open the presentation in here. Let me see. Maybe here. Can you see? But in a small size?
Yes.
In a small size, yes.
Can you see it better? Because it's easier for me to navigate the slides in this way. Because I wanted to show him about this. Can you see now? The
Yeah.
write head
Yes.
resolution and
Yes.
writing speed.
Yes.
So the minimum feature size is 0.3, but the minimum lines and spaces, and this is half pitch, okay, is 0.5. So the pitch, the completely pitch between one line and another line is 1 micron, okay? And this is the same for the other writing heads. You have this information in here.
But it can be set as a dark or the clear on the software when you transfer the files. So if I switch it to the dark, does it also mean that the polygon is 1 micrometer and the pitch is 300 nanometer?
But you cannot lie to the tool. I mean, you can change these, but we are talking about the areas that are exposed. It doesn't matter if you change the polarity. You know,
Yes.
the minimum size that you can expose is 300 nanometers. I don't care if you bring it in dark or in clear, it doesn't matter. You change the polarity. Okay, so for example, instead of exposing this, you will have a pitch of 300 nanometer. Maybe this pitch cannot be done.
So can I say that 300
And
nanometer is
as I said, we need to do many tests because for now, we only did for the high resolution because also we needed to buy all the products and they just arrived last week. We did the acceptance, and then what I can confirm is that we can reproduce these lines.
yeah, okay. So we need a test.
Yes, of course. We need to do a lot of tests. Maybe we increase the resolution, who knows, you know? But it's not like I cannot promise you. I can just tell you what we can achieve now.
Yeah, okay, thank you. Thank you, Eric.
Hi, Eric. What focal depth mean?
The focal depth, you have it here for each of these writing heads. 2 millimeter, 5 millimeter, 20 millimeter. In fact, the name of the write head is the focal depth.
But the unit is millimeter, not
yes.
nanometer.
No, millimeter. is the distance that in which each write head can write in focus.
Like a
Yes,
writing field.
so it's in millimeter. Yes, it's not nanometer. In fact, it's here. Can you see here in the table? It's millimeter.
Erica, can you please tell everyone what will be the policy for using the right head? So normally which one is on all the time and in
Yes,
what condition?
I think I mentioned in the beginning, but because the standard one is going to be the 5mm right head, and the high resolution and the 20mm, they need to request. And only, of course, advanced users, the ones that will have the training for the high resolution, or the ones that are proven that they need to use the 20mm, then I will change the right head.
Thank you.
And it's only in the case that is completely necessary, because you guys need to know that every time that we exchange the right head, we need to perform calibrations for the alignment, in case you need to do alignment, because when we change the right head, we are moving a little bit. And we are talking about microns of, I mean, microns of tolerance that you can have in your design. So we need to do some calibration test every time we change the head. So we will change whenever it's completely necessary. So if I have a user that is fabricating, for now, this is the policy, and the policy can be different with time. It will depend on how many users are requiring for example, the high resolution or the 20mm. So if I see that, because now the tool is just new, so I don't know a lot about the usage of the tool, and what are the needs of most of the users. I really don't know. I will know whenever I start, or whenever people starts to use the tool, and then I will decide, because I can change it. For example, maybe Camelia, you asked, and you are the tool owner of GeoL, and you have some days with one mode and writing mode, and other days with another writing mode. Maybe in future it's like this, but for now, because people only know how to use this single exposure, it will be the 5mm one, the standard writing head, which has very good resolution though. It has 0.8 microns of resolution.
Yes,
So,
this is just to remind everyone that they have to plan in advance and to not expect that the right heads can be changed on any moment of the day, but it's a complex procedure and it needs to be planned way ahead. That's it.
yes. It will be performed only whenever it is completely necessary. So if a user is using this, of course, and in future, when I get more people trained in the high resolution mode, maybe the policy will change. I will see with time. It depends on the usage.
Yeah, so even if my resolution or minimum feature size it's like in micrometer scale, like I don't need the 5mm, but it's just gonna take longer time, like 4 hours, but it's okay. So we don't have to.
Yes, it will be very good. Yeah. So let's say the 5mm is the equivalent to the one that we were having in the lead 15, in the previous one. So it's giving you very good resolution. It doesn't matter if you have 100 micron spaces, so it will be very good. So, yeah. More questions?
Eric, I have one more question.
Yes, go ahead.
So there's a step of centering the substrate of the mask. Does that mean we also make the 0, 0 coordinate in the middle of the mask?
Excuse me, can you repeat?
So I saw there's a process of centering the mask before we start the exposure.
Yes.
Does that mean the 0, 0 coordinates is also in the middle of the mask?
Yes.
Yeah, I ask this because in the mask software, we need to set the 0, either in the middle of the design or in the left bottom of the design. So does that mean we also need to set the 0 coordinate in the middle of the design before we prepare the file?
Yes, I mean, because one thing is what it's not setting the 0, okay? Because what the tool is doing when you load the sample is just scanning the full area to detect what is the edge and then calculating exactly what is the center, not the 0, because there is no design now for now. When you just load the plate, the tool knows where is the center of the plate, okay? And normally what the tool is doing is bringing the 0 of your design to the center of the plate. That's why I explain while you are designing, make the center of your design, not the plate, the center of your design coincident with the 0 of the design area, okay? Of the coordinates of the window of the design software. Make it coincident. So the center of your design will be exposed in the center of the plate. Did I answer?
Yes, that's what I thought.
Can I add something?
Yes.
I think when designing, you should focus on the design which will be centered on your wafer after exposure, because this is the most important. The rest, which is not centered all around, will be just labels for your mask itself. That's what I saw, I mean, from last exposure that I did with the tool. So just focus on what is centered. You should center the area which will be exposed on your substrate, on your wafer. This design should be centered in the 0. It's make it really easier. Thanks.
So there were few slides more that I didn't show previously, but I was explaining while I was giving you all the steps for the file translation and explaining what are so here in the presentation you will have it. What are the shortcuts on the desktop of the PC? What are the formats that are accepted for the 2D photolithography? And these design rules that I was telling you, like the origin that we were talking about, like the areas, like try to avoid enclosing polygons inside of other polygons, or also you have to remember if you use polylines to close completely, because if you have one open area, it will be ignored in the best case, or it will give one error, okay? After the layer, like create the whole design in only one layer. Well, exactly, it's not like this. You can create the design as you wish, it's your design. But this means bring just one layer per each file that you want to expose. The naming, do not use special characters. And again, the polygons is about the polylines. And also, because I didn't show you in the program, but there are several Boolean operations that you can do, or logic operations that you can do if you have several layers and you just want to combine them. And here is just explanation, because when you use the CIF format, it's not giving you these options. But when you are using GDS or DXF, yes, it's giving you the options to combine using OR where you see the both layers are added one to another one, you can choose cut. And then with the second layer, you will cut the first one and it will be removed completely, or you can choose short. Do you remember the option short that I showed you in the software? This is what will happen, okay? So you have two polygons that are coincident in different layers. So the area that is coincident will be removed. That's why this can help you to avoid problems when you have polygons enclosing other polygons. And you have this in the presentation. So for me, the best format is, if I have to say something, is CIF. It's more simple to use, but you can use any of them. I mean, this is not like you have to use CIF. You can use CIF or DXF or GDS. And so nothing else. Any other questions? Please go ahead. No?
Hi, Erika.
Yes.
Are you gonna send us only training this PowerPoint and SOP?
Yes. Yes.
Or could you please send us this recording to us? Is this possible?
Yeah, this is what I mentioned in the beginning. I will send you the recording, I will send you the slides, and I will send you the SOP. I have to say that this SOP is not the final version, okay? Because I was running literally to finish this version, but at least to give you all the steps to do this exposure. But I need to complete many of the other parts of the SOP, because in the SOP we will have the alignment, we will have the high resolution, we will have all these more advanced operations will be included, but not in the current one. Okay, so the SOP that I'm providing today is just helping you to perform this, what I explained. So you will be able to expose, but it's only for this single exposure. Okay. It's giving you as well the parameters for mask, the standard parameters for the mask exposure. And the basic parts of any SOP, of course.
Okay, thank you. Thanks so much.
Yep. So I will send to all of you. Does anyone know? Because I don't know now. Maybe someone of you can help me but because if not, I will go to the recording to know exactly who attended this. If not, I will go through the recording. Anyway.
I made screenshots of the pages of the attendees.
Okay, anyway, we will have the recording, so it's okay. So another thing is now the qualification session. I was going to prepare one slide, but I couldn't because it was in the last minute that they told me this new feature in Infinity, and it was finished this recently. But I'm going to schedule a lot of qualification sessions to have enough for all of you, starting on the 2nd of April, okay? So to get the access for these qualification sessions, first of all, you need to request through Infinity the access to the tool. And if you attended this training, I will accept you. So after I accept you for the tool in Infinity, you just have to go to the tool schedule, and there you will see the qualification sessions. Maximum 4 persons per each qualification session, okay? And you just need to go there and register for the session. I think even though I will send you as well, because Basil will help me, and he told me that he will send me like kind of an SOP or instructional file on how to request these qualifications. But as I said, it will start on the 2nd of April, these sessions. And I think I will have all of these in the Infinity prepared for the 28th, 29th of March. So I will send one email as well for the users. And then you can say, like I will say, now the qualification sessions are open, you can register. And then you just go ahead and register yourself.
Erika, is it one-to-one qualification or a group?
It will be in groups of 4.
Okay.
But I will be doing the qualification one by one. And you just need to show me what I did. Just simple exposure. Yes, I need to see that you know how to load perfectly a sample, and you know how to use the exposure wizard, and you know how to translate your design. So if you want to bring your design, perfect. If you just want to use the design that I have used, perfect as well, because I just need to see that you are confident enough to do this. That's why I want to send you this recording. I want to send you the SOP, which with all the steps, and then after I will see you doing it. In the moment I see you are confident enough, and for all users, it will be very easy. For the old users of the previous tool, it will be super easy. For the new ones, I will give access as well for the tool. But the new ones, if they want to fabricate the photo mask, they will need to go through another training, because this is just for the exposure, and then later you need to process your sample, right? So I will have to train you as well on the mask processing. More questions?
Eric,
Yes.
Can you introduce the application of gray exposure?
Grayscale? No. This is advanced as well. Grayscale, alignment, high resolution, and automatic processing. These 4 things are all different advanced training. And you have to be already an experienced user of this tool to request that training. And this training will be open later on.
Thank you.
In fact, the grayscale, listen, still staff need to be trained. So you can imagine. We are waiting for the last training from the company, because also we are going to be using Beamer to make or to adjust the parameters for the exposure when we're doing grayscale, and to get better results. Okay, so it's going to be more complicated, and still we need to receive the training. So we will develop the training for users whenever we finish our training. And it will be announced the same way I announced this one. I will announce when we open the grayscale training and everything. Any other questions? No? So here, I wanted to just put a picture of one of the samples that we did during the acceptance test of the tool. So we can prove that we can reach 300 nanometer lines. And that's it. Thank you for your attention. Hope you like it.
Thank you for the presentation.